Today we are going to be looking at stretches, compressions, and reflections. So yesterday we just looked at translations, so moving our graph up and down, left and right, and now we're actually going to stretch our graph, compress it, and reflect it. Okay, so this slide is quite important. So we're going to look at our transformations. This is very important for our class. So I would recommend pausing the video as this comes up and writing it all down, making sure that you have a good detailed note on this, okay? And you'll be referring back to it. So our A is going to be a vertical stretch or compression. And the key here is going to be that A is going to be what changes our amplitude. So remember, our amplitude from our very first lesson was from our equation of our axes up to our maximum, or equation of axes down to our minimum. We will look at it again later in this lesson. Okay, our K value out front is a horizontal stretch or compression. So A is vertical and our K is horizontal. Okay, so it is going to change our period. So normally our period is 0 to 360 degrees when we graph our sinusoidal functions. However, if we have a K there, we're going to take 360 degrees and divide it by whatever that K is. Okay. A key here as well is don't forget to factor. I will get into examples where you're going to have to factor, okay? But that is key there. That's how you're going to find your period, okay? We looked at D yesterday. It's our horizontal translation. You can also hear it called your phase shift, okay? And then for C, you have a vertical translation, which changes the axis of the curve, okay? That's going to move your graph up or down, so it's going to change our axis of our curve. So that's really important. So we're now putting together our transformations as well as what it's doing with our amplitude, our period, our phase shift, and our axis of our curve. Okay, so pause this, make sure you have this written out. It is important. Okay, now that you have that graph copied out, or not graph, that slide copied out, I'm going to show you an example of our having a value. A is in front of the sign, okay? So you know that it is an A value. So for that, we're going from our green graph to our red graph, okay? So again, it's going to be easiest if we are using our table of values. Same as yesterday. This doesn't change ever at the beginning. Okay, and then because our A is a vertical stretch and compression, you are going to be affecting your Y values, right? Vertical is up and down. So you're going to take your Y's and we're going to multiply our Y's by 5. Okay, so 0 times 5 is 0, 1 times 5, 5, 0, negative 5, and 0. Okay, nothing has happened to our X's here, so we just leave them. So you have new points. So we have the 0, 0, 95, 180, 0, 270, negative 5, 360, 0. Okay, and then you would plot those points. So 0, 0, you're going over to 90, up to 5, then 180, 0, over to 270, down to negative 5, and then 360, 0. And you would draw that graph, that red graph. Okay, so notice that it affects our vertical affects our Y values. So you're going to multiply. If it was like a half, we would divide by 2 or multiply by a half. Okay, X's are going to be affected, and I'll show you by horizontal, but I'll show you that on the next slide. Okay, sorry, I'm going to show you compression here. So again, and we have a negative. So that negative means that it is a reflection over our x-axis, and that is a vertical compression by a factor of a quarter. Notice that I only put a quarter there. I don't put a negative a quarter because the negative a quarter is taken care of by when you say that reflection. Okay, so just be careful there. So again, easiest to graph. Same thing, write out your base graph. Oops, 270, 360. Okay, it's still in front of your sine x, so it is going to affect our y. It's still an a value. So we're going to multiply by negative 0.25, or you could divide by 4. It's up to you. Okay, so 0, this one's going to become negative 0.25. 0, this one's going to become positive 0.25 because you have that negative there, and then 0. Okay, so then your new pairs become 0, 0, 90, negative 0.25, 180, 0, 270, positive 0.25, and then that 360, 0. Okay, so you would go on your graph and mark 0, 0. Your scale has changed a bit here. Okay, so you're going over to 90, down negative 0.25, 180, 0, 270 up to 0.25, and then 360, 0. Okay, so you'll notice your graph, because it's a compression, it's gotten shorter, right? It is compressed vertically on your y-axis, so it's not as tall anymore. Okay, so that is what you get for a vertical compression. Okay, I'm going to go through another example here, putting a couple of transformations together. So what I'm going to get you to do is graph negative 2 sine x minus 3. So that negative 2 here, that's a reflection in the x-axis. That 2 is a vertical stretch. Forgot the word there. Vertical stretch by a factor of 2. And then this is going to move us down 3 on our graph. Okay, so when you do that, we're going to set up our table of values. Let's go over here. Actually, let's go over here. Again, write out your original. Okay, so your y and doing your reflection is what you're going to want to do first. Okay, so because you know that it is vertical, it affects your y's. So we're going to multiply by negative 2 here. So 0 times negative 2 is 0, negative 2, 0, positive 0. And then because we're moving down, we also on the same side are going to have to minus 3 here. Sorry, I'm going to go to a different color. Okay, so 0 minus 3. Okay, so your new points here are going to be 0, negative 3, 90, negative 5, 180, 0. Nope, sorry, negative 3. Read my wrong. $272 and 360, negative 3. Okay, so you're going to go in plots. You're going to go 0, negative 3, 90, negative 5, 180, negative 3, 272. Wow, I do not know. This is not right either. I apologize. Should not be 2. What should it actually be? 270, negative 1. There we go, 270, negative 1, and then 360, negative 3. Okay, and then you would connect those points there. Okay, so again, they drew the original graph there, then they reflected it and stretched it by 2, and then they moved it down, the 3, okay? Depending on what you feel most comfortable with, I would highly recommend this chart. It's easier and easier, and then you don't have to draw so many graphs, okay? So up to you, but I would highly recommend this graph or this chart, okay? So another example is when we have a K value. So notice that our K comes after the sign. Our A values that we just looked at were before the sign, okay? So just be careful with that. So if you see something out front, it's A, it's vertical. If you see something between the sign and the X, it's going to be a K, okay? So your original graph is 0, 91, 180, 0, 270, negative 1, 360, 0, okay? And what you have to do to find out how you're going to affect your period, remember that our K value is affecting our period, is in our table of values. So I'll show you how this one works. So 0, 90, 180, 270, 360, 0, 1, 0, negative 1, 0. Okay, because it is your, it's in front of your X, it's going to affect your X values because it is a horizontal. Remember, horizontal is your X-axis. Okay, so what you do is you're not going to multiply by 2, but you actually do the opposite. So you're going to divide by 2. So you're going to take 0, divide by 2 is 0, 45, 90, 135, and then 180. And then nothing has happened to our y's. We have no other transformations. So you're going to get new point 0, 0, 45, 1, 90, 0, 135, negative 1, and 180, 0. So you're going to go 0, 0, 45, 1, 90, 0, 135, negative 1, and 180, 0. So that is your graph. Remember, from that very first slide, that K changes the period, and they gave you a little formula to be able to figure out. So you always remember our regular period on this graph is 0 to 360 degrees. Well, we now have a 2 out there, so it's going to affect. So we're going to take our 360 degrees and we divide by whatever our K is. Well, 360 degrees divided by 2 is 180. So you can see that our new period, one full cycle, remember that language from the first day, so one full cycle, which is also called your period, is 100 from 0 to 180 degrees, so it's 180 degrees. Okay, so this would be your new period of your graph. Okay, so that is the way how you're going to calculate it as well. Okay, so we'll go on to another couple of examples of determining your period given an equation. Okay, so determine the period in degrees of y equals sine of 3 theta. It doesn't matter. This would be the same if I said y equals sine of 3x. It doesn't matter. It's the same thing, okay? So we know that our regular period for y equals sine theta is 360 degrees. Every sine graph without being transformed is going to be 360 degrees, right? And then we know that y equals sine 3 theta is compressed horizontally by a factor of 1/3 because we are dividing by 3. So we're going to take 360 and divide it by 3. It's actually going to compress. So again, just like when we look at our movement left and right. So remember, this is opposite of what you see. This is kind of the same thing. So this is like opposite of what you see. So it looks like it would actually stretch it by a factor of 3, but it's actually compressing it by 1/3. Okay. Okay. So the way that you would figure this out without graphing it is you're just going to take 3 theta is going to equal 360 degrees. Divide both sides by 3. And then you're going to get your theta is 120. So the period of sine 3 theta would be 120 degrees. Okay, so you should know how to do that math without having to draw the graph to figure out what that period is. Okay, so copy that out. Make sure that you know how to do that. We'll go into another example on the next slide. We're going to find the period in radians. Don't get scared because it says radians, for y equals cos of 0 of theta divided by 4. Another way of writing this is y equals cos of 1/4 theta, okay? And don't get scared that it's cos instead of sine. Cos graph, if you remember from the first day when I showed it to you, it still has a period of 360 degrees. Or remember that 360 degrees is equal to 2 pi, which is the radians, okay? So we're going to just work with 2 pi right now rather than 360 degrees. Okay, so our regular cos graph is equal to 2 pi, or 360 degrees. The graph of cos theta divided by 4 is stretched horizontally by a factor of 1 all over 1 over 4, or 4. You don't really have to write that for me. Okay, just write that 4. So remember, it's the opposite of what you see. It looks like it's divided by 4, but it's actually going to stretch us by 4. Okay, because if we set theta divided by 4 from our equation equal to 2 pi, well, then how to get rid of that? Multiply both sides by 4. So that cancels out. You're left just with theta. 2 times 4 is 8 pi. So then the period of y equals cos theta divided by 4 is 8 pi. 8 pi would be like saying 2 pi, which is 360 degrees. 360 degrees times by 4. So to put that into perspective, that is going to be a big number, 14,440 degrees. Okay, so that is kind of the same thing. So you can picture that. So your graph is going to be stretched out quite far horizontally. Okay, so copy that example out as well. This next one, I want you to state each phase shift. So remember, our phase shift is, if we look at our function, our D is our phase shift, okay? So we have to figure out what our D is, but for this first one, we need to remember to factor, right? 4 theta. So you could look at this and say, oh, it's 180 degrees, but this 4 theta is actually going to affect it, so we need to remember to factor. Okay, so once you remember to factor, you're going to take each of these, divide it by 4, right? You want to get theta by itself. So divide by 4 and pull the 4 out front. 180 divided by 4. So then the way that you're going to write this is equal to y is equal to cos 4 theta plus 45 degrees. That's just 180 divided by 4. Okay, so then you know that the phase shift, remember, is opposite of what you see. So it's opposite, so it's left 45 degrees. Okay, so we aren't worrying about this 4 right now. We want the phase shift. If I asked you what the period was, you would take 360 degrees and divide it by 4 and know that it's 90 degrees, okay? But I didn't ask you that, but that's how you would calculate that, okay? For this one, we see that it is already factored. So since it's already factored, you're just going to look in your brackets at where the D value is. It's plus 15 in our equation, so we know that we need to write it as opposite. So it is left 15 degrees or negative 15 degrees. Okay, you need to either write the negative or the left there. You can't just write 15 degrees. Okay. Couple more examples here. Y equals 3 sine 5 theta plus 180 plus 4. Okay, I want to know what your amplitude, so we're putting it all together here, what your amplitude is, what your period is, what your phase shift is, and what your axis of your curve is. Okay, the one thing you need to remember to do before you can start this stuff is to factor. Okay, so what we're just going to do is factor out the 5 theta. So y is equal to 3 sine, you want that 5 out front, theta, and then you just do it by getting rid of it is taking 180 degrees, and you're going to divide it by 5. So 180 degrees divided by 5. is 36. And then you're going to go plus 4. Okay, so you need to remember to factor first, and now you're going to use this equation. Okay, so some things that are really easy. Your amplitude is your A factor. Your A is equal to 3 in this question, so you know that you're going to vertically stretch by a factor of 3 for this, because it's out front of your equation here. You know that it is just going to be that value, and that is your amplitude. Okay, your period, remember, is your K value. Your K value in this example is 5. Okay, and then your period, though, it is in 5, but then you need to make sure that you're actually determining your period. So you need to take 360 degrees, divide it by 5. So you're going to have a period of 72 degrees. Okay, or if you wanted, remember, you can do 5 theta is equal to 360 degrees. Divide both sides by 5. Theta is equal to 72. That was on that one slide, okay? It's up to you. You can do either or here, okay? Our phase shift, because we already factored, is nice for us. And we can, our phase shift is nice. We can just look here. That is our D value, okay, which is equal to positive 36 there. So that means that we are going to move left 36 degrees, right? So remember that our phase shift is left. It's the opposite, or you need to write negative 36 degrees for me there, okay? Because it's opposite of what you see. And then our axis of our curve, we actually haven't looked at too much yet in this, other than the very first slide. It is just the number that is your C value at the end of the graph, and that is equal to 4. So your new axis of your curve is equal to y equals 4. So it's just what splits your graph evenly, right? If you had your graph here, it is going to be, ooh, that's terrible. That's going to be equal to 4 there. And then you're going to have your max and min below that 4, but all 3 of your points would be on y equals 4. Okay. So that is kind of putting everything together. So make sure you write that example out. And then we also have another one. I'm actually going to add your equation of your axes here as well to an extra spot on this. And what I'm going to do is I'm not going to fill this in right now, but I'm going to get you to do it. So copy it out, okay? And then we will take it up in our synchronous lesson tomorrow, okay? So just make sure that you copy this out. Try it on your own. It does not help for you to copy it out and leave it blank and wait for me to do it. Try to do it yourself, okay? So amplitude, I'll do the first one with you. Amplitude would be 5. Easy, okay? Your period is normally 360 degrees. You have to take and divide it by whatever your K value is. So your period is now 180 degrees. We have no D value, so our phase shift is either none, not applicable, or you can write no phase shift. Okay, so up to you what you want to write there because you have no phase shift. Your equation of your axes would be, if we had a C value, we don't, but you can't write no equation of your axes because one still does exist. You just haven't changed it from your original equation of our axes, which is at y equals 0. So you still have to put y equals 0 there. Okay, so complete the rest of them. Try your best. Don't forget to factor. And we will take them up tomorrow. Okay, that's what we'll do in our lesson tomorrow. Okay, so good luck with that. Once you go to the next slide, your homework is posted here. Okay, just let me know if you have any questions with either the chart or the homework, and good luck.